Okay, now it's time to convert the memoization solution to a tabulation. In order to make it easier, let me duplicate this whiteboard. So if I duplicate it, so let's go here, and I don't need these calculations for now. Let me erase them, and I want to make it a little, and actually erase all of these comments to make it a little more readable. Okay, and I wanna, because I wanna convert this, and I don't have enough space here to show how I'm doing this. That's why I wanna zoom out this code, because I want to show you how we want to convert this guy to a tabulation solution. For tabulation solution, let me write the steps first. We have some steps. If you follow these steps, you will see how easy it is the conversion process. First of all, we have to step one. Step one. In the step one, we have to define DP matrix. I name this, in tabulation also we have a matrix. I name this as a DP matrix, and in memoization, as you saw, I'm using a memo matrix. They are so similar, but I changed the names to differentiate the difference between these two approaches. First of all, we have to define DP matrix based on memo matrix. Based on memo matrix. So, okay, let me do this first as a first example. Okay, so we have to define this. In most cases, it is exactly equal to memo, but sometimes we need to add some rows, or one row or one column. How we should detect we need to do that? It will be done in the step 2. In step 2, we want to initialize DP matrix based on base cases. Okay, let me do these two guys right now, and then we will go for the next steps. So step 1 is DP. So if you remember, I said we have a in the previous in memoization approach, we had a memo matrix, right? Like this. We had a memo matrix I and J, and we said J goes from 1 to 0 to P, and the I goes from 0, 1 to T, right? Because we have text here, and we will have pattern. We want to traverse pattern by using the J index. And if you remember, we traverse, actually you can see here, we are populating, we are calculating all the values of this memo matrix with these recursive calls, and we are adding these guys here. In tabulation, we don't want to do anything new. We want to do in the same task, but in memoization, we do the top-down approach. We start from the the highest level, and at the end we have base case, and we return some values. But in the tabulation, we will define a DP matrix, but first of all, we have to initialize the DP based on the base cases, which is the step 2. For now, let's say our DP matrix is exactly similar to memo. So this is the first step. We specified we need exactly a matrix similar to memo matrix. Second step is to go and check the base cases. We have only base case here, right? And it is if J is equal to len of pattern. It means that if J is equal to len of pattern means this column. Let me write with the red color. If we are here, return I is equal to len of text. So let's say our text, the length of text is t, right? So we are converting this base case to the initialization of the DP matrix. If J is equal to len of this, we can initialize all of these cells. So what will be the value for this cell? J is equal to len of pattern or P, and I is 0. I is not equal to length, so we will put false here. Same scenario for 1. It is not equal to T, so we'll have false. All of them will be false, but the last cell will be true because this condition is true. That's the step 2. Okay, so we have we did simply DP matrix exactly similar to memo. We initialize the DP matrix based on the base case. The next step, as you see, we don't do any special thing here, right? We directly converted right now the base case to initialization and the memo to the DP. And third step is converting. Let me write here. We wanna step 3. Convert recursive calls to DP formulas. So what does it mean? We want to convert all the recursive calls to DP formulas. Let me write this a little better. It is not readable, I think. I'm writing really small. Okay, so let's go and find that the recursive parts. Actually, we have all of these guys, all of the recursive calls are in this area, right? So let's go and do this. I want to change the color to this color. We have a recursive call here. Actually, we are updating the memo ij. Whenever we are updating or we are setting the memo ij, we need a DP formula. Also, we need a DP formula for this line. How can I convert this to the DP formula? Instead of the memo ij, I can write DP ij is equal to, whenever you have a recursive function, recursive call, you should write DP. Okay, so you will write it is equal to DP of, what is the index? I and j plus 2. Only you have to worry about the indices. So it will be I j plus 2. Or as you can see, I'm converting directly the recursive call to DP formula without any rethinking about the problem. And here again, we will do for helper, and for this function call, we have to write the DP formula, and we have to write this exactly same as we have in the for memoization. So we write current match and dp of I plus 1 and j. Okay, this is one of the formulas, and this guy formula is the same, right? It will be dpi j will be equal to current match and dp of I plus 1 and j plus 1. So this is the third step. So we have the first, for step 1, step 2, step 3. As you can see, we don't do it, I'm emphasizing that we don't do any, so far, first 3 steps, we didn't do anything new without thinking about the problem. So we have the recursive formulas. We will keep all of these guys same as, let me, same as the memoization. We don't need to do anything. So let me put all of these guys here, all of these, the recursive formula, DP formulas, instead of these guys, this and this. I'm going to only simply replace them. So let's go and erase these guys. I'm simply converting this guy. If I wanna do this in the editor, that would be much more faster, definitely. But I wanna do this in this way to show you. I need to zoom out. So if we have this, instead of recursive call, we will do this. Okay, that's it. And let me move these guys up a little. Make it a little better. Okay. And also I need to raise all of these guys. And I will bring the DP formula. And I will replace all of those guys with the DP formula. Here I need to maybe the scale will be a little different. Okay. I need to move it a little. Okay. So we did all of these guys, and we don't need to have this. This is for memoization purpose. And you need to raise all of these guys. Because base cases will be handled in the initialization part of this. And I will do this right now. And because we are doing the DP, we don't need to have a top level caller. We don't need all of these guys. And we don't need memo and I and j as an input, because we want to handle inside of the function. Okay, let me. Okay. So far we did. Let me write the code for step 1 also. I shouldn't, erase, the last part. Sorry, let me undo. I need this memo. I need the memo actually. Because DP is exactly like memo. So let me erase all of these guys. We don't need these guys, and only we have the top level. Yes, this is better, more optimal. But only I wanna change this to DP only for. This is DP. We said this is step 1, DP, and we need to initialize the DP. And it's better to put false for all of them instead of none. The initial value can be false for all of them, but we need to make this node true as initial value. So I will write dp -1 -1 as true. Okay, so we did right now all of the 1, 2, and 3 the steps. Let me erase all of these guys we don't need right now. Okay, so what is the next step? Actually, we wanna fill out, populate this matrix. We know these are the formulas to update them, but we need to traverse or populate this matrix. And based on these formulas, we can figure out what should be the direction. I want to start from, let's say the column 0 to the end, or I want to start from, column p-1 to the end, and what would be the direction of the rows. So let's go and write, the description of the step 4. So in step 4, which is the most important part of the tabulation. Actually, in the method I'm teaching, all the steps are really straightforward. Only in step 4 you have to do some simple calculations to figure out what should be the population direction. So it will be detect the DP populating direction. What does it mean, directions? It means, how we want to go play with I index and how we want to go play with J index to populate all the cells inside of the DP matrix. Let me do this, like say we have 5 columns and make it a little simpler example. Let's say this is 0, 1, 2, 3, 4, 1, 2, 3, 4. I want to go and do this with only one example, and we will figure out how we will we have to populate this guy. Let's say we are in this cell, and I want to calculate the values of this guy. I mean, if I want to calculate dp of I and j, which is right now dp of 2 and 2, I need I and j plus 2. I and j plus 2. It means that I need, if I want to calculate 2 and 2, I need this guy. If the case 1 is true. Also, if the case 1 is true, also I need I plus 1 and j will be this guy. If the case 1 is not true, I need I plus 1 and j plus 1, which will be this cell. So it means that in order to calculate this cell, which is 2 and 2, I need these circles, right? This one and this one and this one. It helps us to detect that for every row I need the next row and some values of the same row, but the value is the higher indices, right? It means that if I start from this cell, I can calculate this one, and I can go in this direction, and then I can go in this direction. I can populate all of these guys. So we figured out, based on only some simple example, that I can go in this way and populate the matrix. So how can I do that? J will go from, so let's detect, what is that J direction. J will go from, this is P, this is P minus 1. This J will go from P1 to 0, and I will go, as you can see, the I direction will start from 4, will go to the 0. I will go from T to 0. This is the most important part, which is needed to think a little about your answer. So I need 2 for loops to put over all of these calculations. So let me, because I need to have for loops on top of this, I need to move this a little here because it is my body of my algorithm. And let's go and write the for loops. I want to write with blue color. So I will write for J in range P minus 1 is len of pattern. It is better to save the len of pattern and len of text in some variables. P minus 1 will be len of P minus 1. I want to go to 0, so it means decrease in direction. I will go write -1 because in Python it is not inclusive, so I have to write -1 to have 0 itself. And what is the direction? -1. So this is, the end point. This is the start point. And this is the direction for the people who are not, familiar with the, Python. So this is for J, and let's go and write I. For I in range T to 0. What is T? T is len of text -1 and -1. And that's it. We did, the step 4. And step 4, the directions, and actually we have 2 operations here, right? We have to detect the directions and then write the for loops. So this is the result of the step 4. And step 3 was, these guys converting, the recursive calls to, and step 1 and step 2 actually was, the base cases. These guys also are, the step 1 and step 2, the first 2 lines. And the last cell we are calculating, which will be this cell, is the answer. Because when we are here, it means that we traversed whole pattern from top, from the end to the beginning, and also we traverse whole text. So the value and in that cell will be our answer, and we can simply return. Let me do this here. Return dp 0 and 0. That's it, and we are done. And I can go through some examples to show you how this is populating, but you can do yourself. Actually, only thing you need to know what is the direction. I saw lots of my students, lots of people who are doing all calculations manually for this matrix. You don't need to do that. All thing you need to do is detect what is the relation. Actually these guys, you can select one of the cells like we did here, and you will detect, in order to calculate that, which values you are you need to know, and based on that you will detect what will be the direction of the populator, and that's let's put it, those nested loops on top, and it is done without any struggling. I mean, this is, I try to teach in non-struggling way, really hard and difficult concepts. And as you can see right now, we have the time complexity is same as memoization. Time complexity is order of TP, because we have two nested loops and we traverse, and the space complexity also is the same because we use the DP matrix. So we have only one final step, which is converting. We have to check it. In some questions, we can decrease this to order of P. It means that we don't need to have whole matrix. As you can see here, in this matrix, always we need only one row. If I'm calculating all the values of this row, I don't need to know all the values of these three rows. I need only the next row. So I can handle all these calculations with only two rows, and it will be 2 times P. In terms of big O, we will say it is order of P. And this is order of P, actually, like I said here. And this is the power of tabulation. You can decrease the space complexity. And also, in some scenarios, I said before, we prefer to have iterative solution instead of recursive solution in some applications. In the next whiteboard, I want to go and convert this tabulation to the optimal version in terms of a space complexity. And you will see how easy we will convert this to 2 rows. And this problem will be done. And actually this session will be finished. Let's go and optimize this to the space complexity of order of P by decreasing the DP matrix to only 2 rows.